Multiple interrupt. Larger number of interrupt generator, keyboard, mouse, hard disk, cloud memory error. Which interrupt is important? Which should be handled first? Is both of them occur simultaneously? Okay. How will you identify the module issuing the interrupt? Based on multiple interrupt line, software pool, daisy chain, bus arbitration. Device multiple interrupt line, device identification. Different interrupt line for each module, limit number of device. Even with this method, there are often multiple interrupts still on single interrupt line. Okay, handle which interrupt. Priority is set by hardware. This is example of the multiple interrupt, single line interrupt request and multiple interrupt request. See the multiple line interrupt request. There are a lot of the tasks need to do. Software pool, device identification. Single interrupt line, when interrupt occurs, CPU then goes to check who need extension. How? Interrupt service routing pool is input of a module to determine which module caused the interrupt. It will become slow. Software polling flowchart. After device identification, the processor then branch to the appropriate interrupt, handling routing address for the given device. Handle which interrupt. The order in which the device appear in the polling sequence determine their priority. Software polling limitation. It is wasteful of the processor time as it needs to check the status of all devices all the time. It is inherently slow as it checks the status of all input-output devices before it comes back to check any given one again. When fast devices are connected to a system, polling may simply not be fast enough to satisfy the minimum service requirement. Priority of the device is determined by the order in the polling loop, but it is possible to change it via software. Daisy chain. It is significantly faster than pure software approach. Daisy chaining is used for level-sensitive interrupt, which act like a wired or gate. Any requesting device can take the interrupt line low and keep it set low until it service. Bus arbitration. Device identification. Each device has a request line connected to a centralized arbiter that determines which device will be granted access to the bus. Device that win place vector on bus uniquely identifying interrupt. Handling multiple interrupt. Priority is set by priority in arbitration. The order may be fixed by the order of connection, or it may be determined by some algorithm preload into the arbiter. How to deal with multiple interrupt. Each interrupt line has priority. Higher priority line can interrupt lower priority line. If bus mastering only, current master can interrupt. With multiple line, the processor just pick the interrupt line with highest priority. With software polling, the order in which modules are pulled to determine their priority. Similarly, the order of module on daisy chain determine their priority. Bus arbitration employ priority scheme. Next topic, we'll talk about bus. A computer consists of set of components, CPU, memory, input-output that communicate with each other. The collection of paths connecting the various modules is called the bus or interconnection structure. The design of the structure will depend on the exchange that must be made between module or device. We require bus to communicate with each other, input and output. The features of bus is the dedicated line for each device to communicate with each other, CPU to memory to scanner or CPU speaker. How many type of bus? It is 1, 2 or 3. It is a shared transmission medium, allow connection to multiple devices. However, only one device can transmit data or instruction at a time. Each line is capable of transmit signal represented by binary value 0 or 1. Hence, several lines of bus can be used to transmit binary digit simultaneously. For example, 8-bit unit of data can be transmitted over 8 bus line. The major part of a computer model are the central processor unit, CPU, memory, and the input and output circuit. Connecting this part are 3 sets of parallel lines called bus. This bus consists 50 to 100 separate lines, and each line is assigned particularly function. The 3 buses are address bus, data bus, and control bus. Data bus or data line is provide paths for moving data between devices, consists of from 32 to 100 separate lines. Each line carry 1 bit at a time. A number of lines determine how many bits can be transferred at a time. For example, if the data bus is 8 bit wide and its instruction is 16 bit long, the processor must access the memory module. The data bus line are bidirectional. Many devices in system will have their output connected to data bus, but only one device at a time will have its output enabled. Address bus. The number of memory that the CPU can address is determined by the number of address. This calculated by using 2 power n, for example, with 16 address line can address 65,536 memory. Address bus used to design the source or destination of the data on the data bus. The width of the address line determines the maximum possible memory capacity. Once this line, the CPU send out the address of the memory location that is to be written or to read from. Control bus used to control access to and the use of data in address line. Because data in address line are shared by all components, hence the control line acts as mechanism to control their use. The CPU send out signal on the control bus to enable the output of address memory device. Typical control bus signal are memory read, memory write, input output write, bus request, interrupt request. Let's see how reading and writing to memory. Okay, read from the cell 09 and it put in the RAM. And then it will write 03. As you can see, to write 03 or 06, they must have slot. This we call a memory.